Hello legal hustlers. In today's video, we will be discussing the nature of logic, which is the study of reasoning and argumentation, where you will learn about the principles of deductive and inductive reasoning, the structure of arguments, and the importance of critical thinking in logical analysis. So, let's get started. What is logic and its aims? The word logic comes from the Greek word logos, which has a variety of translations, such as reason, discourse, or language. So logic is the science of reasoning and argumentation. It is concerned with the principles of correct reasoning and valid inference. The study of logic helps individuals to reason more effectively, make better decisions, and develop critical thinking skills. Therefore, by studying logic, we can develop our critical thinking skills, hone our ability to evaluate arguments, and better understand the fundamental principles of rational thought. Let's see. Aims of logic. To evaluate the validity of arguments and reasoning. To identify patterns of valid reasoning and analyze arguments. To promote clear and precise thinking and avoid fallacies. To improve decision-making and reach sound conclusions. To develop critical thinking skills and evaluate complex ideas. To provide a foundation for other disciplines. To apply rational principles in a variety of contexts. Overall, the aim of logic is to provide a rigorous and precise framework for reasoning, one that can be applied across a wide range of contexts and fields. Why study logic? There are several reasons why one might want to study logic. 1. Improved reasoning skills. Studying logic can help you develop better reasoning skills, which can be useful in all areas of life. By learning how to identify and evaluate arguments, you can make better decisions and avoid common fallacies. 2. Clear thinking. Logic can help you think more clearly and express your thoughts more coherently. You will learn how to break down complex ideas into simpler parts and analyze them systematically. 3. Problem-solving skills. Logic provides a structured framework for problem solving. By learning how to identify and analyze problems, you can develop effective strategies for finding solutions. 4. Enhanced academic performance. Logic is an important part of many academic disciplines, including philosophy, mathematics, computer science, and linguistics. By studying logic, you can improve your performance in these fields and gain a deeper understanding of the concepts involved. 5. Career opportunities. Many careers require strong analytical and critical thinking skills such as law, business and management, finance and accounting, computer science and programming, engineering and scientific research. So studying logic can help you develop these skills, making you more attractive to potential employers. Overall, studying logic is an excellent way to improve your thinking skills, enhance your academic performance, and prepare for a wide range of career opportunities. The history of logic. The history of logic can be traced back to ancient Greece, where philosophers such as Aristotle developed the foundational concepts of logic. Aristotle's work on logic, called organon, included his famous syllogistic reasoning, which provided a systematic method for deductive reasoning. In the medieval period, scholars like Bertius and Anselm built upon Aristotle's work and developed new logical systems, such as the modal logic used to analyze the relationships between possibility, necessity, and contingency. During the Renaissance, logic continued to be an important field of study, with figures like Francis Bacon and René Descartes making important contributions. Bacon emphasized the importance of induction in scientific reasoning, while Descartes developed a method of doubt to test the validity of beliefs. In the modern period, logic has continued to evolve and expand, with the development of mathematical logic by figures like Gottlob Frege, Bertrand Russell, and Alfred North Whitehead. Mathematical logic has had significant applications in computer science, artificial intelligence, and other fields. Today, logic remains an important field of study, with ongoing research into new logical systems and applications in diverse areas of philosophy, science, and mathematics. Traditional and modern definitions of logic. Traditional logic is a system of formal logic based on Aristotle. It mainly deals with syllogistic forms of deduction. It involves the study of reasoning and argumentation. It examines the principles of valid inference and rules for constructing sound arguments. Logic is concerned with identifying good and bad reasoning. It aims to develop methods for evaluating arguments and determining their validity. Thus, Traditional logic is less formal and relies more on natural language. Modern logic emerged in the late 19th and early 20th centuries as a response to the limitations of traditional logic. It is characterized by the use of mathematical methods and techniques to study formal reasoning and language. Modern logic includes propositional and predicate logic, which are formal languages used to represent and reason about statements and arguments. It also includes modal logic, which deals with the concepts of necessity and possibility. Non-classical logics such as fuzzy logic and intuitionistic logic are also part of modern logic. Modern logic has applications in various fields such as philosophy, mathematics, computer science, linguistics, and artificial intelligence. In addition to its theoretical significance, modern logic has practical applications in areas such as database management, software engineering, and automated reasoning. Thus, modern logic is concerned with the study of formal systems and their properties. Basic features of inductive and deductive reasoning. The uses in law courts. Inductive and deductive reasoning are two fundamental forms of logical reasoning used to draw conclusions from evidence or premises. In general, inductive reasoning is used to make generalizations based on specific observations, while deductive reasoning is used to draw specific conclusions from general premises. Both forms of reasoning are used in law courts to establish facts and determine legal outcomes. Inductive reasoning. Inductive reasoning involves making conclusions based on specific observations or data. It starts with specific examples and uses them to create a general principle or theory. Inductive reasoning is used in law courts to establish patterns and make generalizations about evidence. For example, a prosecutor might present several cases of similar crimes to a jury to establish a pattern of behavior that implicates the defendant. Deductive reasoning. Deductive reasoning involves drawing specific conclusions from general premises. It starts with a general principle or theory and uses it to make predictions or conclusions about specific cases. Deductive reasoning is used in law courts to apply legal principles to specific cases. For example, a judge might use a legal precedent to determine the outcome of a case. Uses in law courts. Both inductive and deductive reasoning are used in law courts to establish facts and determine legal outcomes. Inductive reasoning is often used to establish patterns and make generalizations about evidence. It is particularly useful in cases where there is no direct evidence of wrongdoing, but where a pattern of behavior suggests guilt. Deductive reasoning is used to apply legal principles to specific cases. It is particularly useful in cases where there is a clear legal precedent that applies to the facts of the case. Some basic logical concepts: form, content, truth, validity, inference, implication. 1. Form. In logic, form refers to the structure or pattern of an argument, independent of its content or meaning. For example, the form of the argument, all humans are mortal, Socrates is human, therefore, Socrates is mortal, is, all are a B, X is A, therefore, X is B. 2. Content. In logic, content refers to the meaning or substance of an argument. It refers to the actual statements or propositions that make up the argument. For example, the content of the argument, all humans are mortal, Socrates is human, therefore, Socrates is mortal, is the statements, all humans are mortal, and Socrates is human. 3. Truth. In logic, truth refers to the correspondence of a statement or proposition with reality. A statement is considered true if it accurately describes the state of affairs in the world. For example, the statement, "the Earth revolves around the Sun," is considered true because it corresponds with the way things actually are. 4. Validity. In logic, validity refers to the relationship between the premises and the conclusion of an argument. An argument is considered valid if the conclusion necessarily follows from the premises. For example, the argument, all humans are mortal, Socrates is human, therefore, Socrates is mortal, is considered valid because the conclusion logically follows from the premises. 5. Inference. In logic, inference refers to the process of deriving a conclusion from one or more premises. It involves drawing a logical conclusion based on the evidence or information available. For example, in the argument, all humans are mortal, Socrates is human, therefore, Socrates is mortal, the inference is that Socrates is mortal based on the premises. 6. Implication. In logic, implication refers to the relationship between two propositions where the truth of one requires the truth of the other. For example, if we accept the statement, all men are mortal, as true, then it implies that the statement, Socrates is mortal, must also be true, as Socrates is a man. Thank you for watching. We're thrilled to have you here and hope that you find our content informative, engaging, and entertaining. Be sure to like, share and subscribe, and don't forget to join us for further updates.